talk about some other stuff while it's doing that. So Lime that I told you about with the sparse linear model, there is a specific package for called Lime, which is an R port of the Python Lime package, but it only supports some packages. So Caret, for instance, which is a nice package, but it doesn't support most other things out of the box. So, and I also ran into some other problems. So I prefer to use the Lime implementation in IML, the package that is based on the ebook. So that's what I'm going to run next. And IML also has the game theory stuff, the Shapley value. But now we still have to wait for the XGBoost explainer. And the XGBoost explainer will give, I don't know if it's called like a waterfall plot or something, but it will show sort of a view of how much each feature is contributing to the prediction at hand. At the end of this piece of code, I had some extra stuff from Daleks, which I just put in there because it's a nice thing with that is that you can easily compare different models. For instance, if you have a linear regression model and a random forest model, you can get all of these diagnostics in the same plot, and you can very easily compare them. So now it's done with that. And then it shows this waterfall model, where this is kind of the expected value, this intercept 22.03, and then the number of rooms drags the prediction down, and yeah, all of the red ones drag the prediction down, and the age drags it up, and eventually you get this prediction at the end of the waterfall. Yeah, and here's just another waterfall just for kicks. So that is one where the prediction is higher. So Lime for the same, I think it's for the first of the predictions with the waterfall plots. Okay, it's because I had to restart. So I had to restart this. Still on Boston, right? So predictor, and then we're here. So then you get this. So as I said, Lime likes to give very compact explanations. So it thinks that it's really important with the number of rooms being what it is, and that increases the price, and the two other ones decrease it a little bit. Whereas if you do it with the Shapley value method, I think it will give a much more complicated explanation. Although it also feels that the number of rooms is really what it's explaining this prediction. So yeah, I don't know. Do we stop here, or?
If people have time, we can continue for a little while. We need to be out here at past the latest. Maybe a few minutes.
Yeah, maybe I can just show that one comparison that I was talking about. These things are actually like that. What I'm going to show now is from the Daleks tutorial. So you can also look at that afterwards. But what happens here is that we build a linear regression model and a random forest model for the Polish apartment data. And they have about the same mean square error, like about 280. and then you can get plots like this, where you see both of them, the residual. So this is the absolute error that it makes, the absolute difference between the prediction and the true price. And as you see, the linear model is as kind of a funky shape. There's something, so something going on there. Maybe some statistical interaction or something like that. The random forest is giving pretty smooth residuals, but the linear model often has it has certain values of residuals that it somehow has, which are more common than the other ones. And if we go ahead a little bit, here is yet another variable importance thing, which is the one built into Daleks, and it's also using this variable dropout or variable shuffling method as in the random forest thing I showed at the beginning. For both the random forest and the linear model, the district is the most important, and then surface. Okay, so they are looking at the same thing, but let's see. Soon we will be able to see why the residuals were distributed like that in the linear model, but not in the random forest, I think. Maybe that comes later. So this is no, it plotted too much at the same time. Yeah. So here we are looking at this partial dependence plot for the construction year. So here you see that the linear model is of course linear. I mean, that's sort of what it does. But the random forest is able to tell that the old apartments are more valuable and the new apartments are more valuable, but the ones built between 1940 and 1990 or something like that are worth less. So here is the explanation for why we had that curve. So so I think this is a quite nice package for comparing different methods, and it implements a lot of nice things, both IML and Daleks. So I guess we'll end here instead. Thank you. Yeah, any questions?
Yeah, thanks. It's really interesting. It's like debugging tools for machine learning algorithms. I was thinking about Bultarion. You're selling a software platform, or you have clients there, and perhaps you have algorithms. Do you see that as the IP of that company that you want to keep closer? Because you were talking about algorithmic transparency.
Mm-hmm.
Do you want to kind of like show that your algorithms are great and look at how, give explainers and so on? Is that towards end users or to customers only, or, I mean, are your algorithms at Bultarion open or closed?
I think there's at least two different questions there. Like if we start with the explanations, it's something that we don't have in the platform right now, but which, as you can imagine, I'm very keen to get in there, and a lot of the customers or potential customers are asking for it as well. So we need to implement something. The IP. I mean, the end users that use the platform own everything that they make in it. So it's not open in that way. With that said, all of the models that you build in it are sort of well-known deep learning models. We have building blocks for those, and it's possible to find out what they look like. but yeah, I don't know if that
Yeah.
answers
So
your
it's like
question.
to build trust in the models that you have for your clients primarily.
Yeah,